Alright, today we're going to continue on with this little a-5, see how things go with it, and we're going to try to hit this in the order that I normally hit stuff in, and to try to give us the most bang for the buck, and as far as capacitors go. And we're going to jump to right to a coupling cap. So what we're going to have to do is just simply take the back off, the back cover, and we can get to these coupling caps, which is going to be C1R and C1L. So we're going to do them first. Now, a nice thing here I see, well, everything is just so easy to work on because it's really, the way it's just kind of layered or sandwiched together here, and there isn't much in it. Kind of reminds me of when I used to open the car hood on probably the first car I ever had. So, there's definitely room to get another heatsink on here. So that could be down the road, and likely will be. So we just want to see where C1R is at, and get that one out of there, and C1L. Right there. So we pulled those two 1 mics out of there for C1. I'm just kind of scratching my head over this one because when I looked in the bag here, these are ones at 50. I don't remember a 1 mic cap being that big in diameter. And you would think I would remember that, considering I'd probably put in 1,000 of them. So I don't know if a 1 at 50 UFG is smaller, or if these Elnas suddenly got bigger. I'm just not sure what I'm experiencing here. But we're going to use an electrolytic for this first and see what that sounds like. There's sometimes that I would use a film cap, but we're going to try these Elna RFSs, and we're going to put them in for C1. I'm still scratching my head over this cap thing. When I looked at the bag of these when they came, I looked in them and I said, well, that looks like they're 10 mics, but they're 1s. I don't know if I'm overlooking the obvious or what here. They don't quite look as big as a 10, but they definitely look a lot larger than a 1. So I'm not sure what I ended up with here. Sometimes you just got to take what you can get, because caps are like that. You just can't find them. I don't know if it's something with a suffix that I'm missing. I don't know. But looking at a UFG, that's a typical 1 mic. So I don't know. Eventually I'll figure it out, I guess. Now, I said we're going to go in the order of significance and most bang for your buck. But since I'm on the heatsink board, and that's where I need to be for this one change, this isn't going to be a significant change right now by any means, but it's going to come into play later on down the road. And I don't even know if I can find them. They're going to be 220s. That looks like that's 1. C2R is up on top. C2L is right here. They're 220s. Since I got this in a place to do this, I think I'm just going to take both of those ceramics out now. That's your swamping caps on the input of that STK module. For high frequency roll off. So we're going to pull both of those ceramics out here. So these are the 220s that came out, the ceramics, and we're going to put 2 PPS chips in there. So that didn't quite go like I wanted. These little PPS chips, especially these real small ones, can be kind of hard to set. So what I do is, I couldn't span the distance here with one reliably, so I just offset it to one side here and just build these up with solder. If you were able to span this distance, just build these up as, you know, a pretty good distance up off the board with solder, and then just put your chip in between and just hit this and swish it to the side. But I couldn't bridge that gap, so I had to offset the cap here. So I just set it up on 2 layers of cambric tape, which is a varnish tape, and we'll just hit one side there, and we'll just take a piece of 30 gauge wire wrap to connect our other side. So that was C2, and right here is the 1, and up here's the other, and they were 220 picofarad. These are the chips I used. They're the Panasonic ECHs. Alright, now going back to the order of significance, as far as I'm concerned anyway, we're going to take these 2 chiclets out here. They should be .022s. Those are your loudness bass boost. And we're going to try to take them down just one value. We got a very small heat sink here, and very small heat sinks don't like bass. So we're not going to get crazy with it, but we're going to try to give it a little bit more bottom. So those 2 chiclets are going to be very easy to find, because they're going to be right on the sides of your switch, and one should be there and one should be there. Flip this around, make sure I'm looking at this at the right angle. This is the first time I've been in an a-5, so I don't want to, I might have made a mistake. Well, I did make a mistake. That's why you always check, because they shouldn't have been on the far ends of the switch. They should have been sandwiched in between the loudness switch, where they typically are. And I didn't see that, and that's what caught my attention. Something didn't look right, because actually right there's one of them, and they're so close in size it's hard to tell. But there's the other one. So we got one on top and one on the end. So this one is right. The one on the end should be this one. And we can verify that's right. It's just it's laid out on the board here a little bit differently than I'm used to seeing as far as other Sansui units go. But coming off your switch, right here we hit one leg, and right here's the cap on the other leg of the switch. All on the same switch, of course. So just a quick little pointer for those that may not know. Solder sucker maintenance is pretty critical when you're tearing into a unit. And I got in a hurry, and I fell short today too. So we have to have a work stoppage here and get this thing cleaned out, because it's an accident waiting to happen. And you can see what happens when you get sloppy on your solder sucker. You end up with a bunch of crap like that, and then you get little chips falling out of the end of it when you try to pull vacuum on it, and the next thing you know they're laying down in there, and you know, sometimes you don't see them, and all kinds of strange things can happen. So it was a sloppy desoldering job there. So there's the chiclets. They're .022s, and that is C9. I'm not sure if I'm going to put a Mylar in or if I'm going to put a PPS chip in for these just yet. Sometimes decisions are solely a reflection of availability, especially in today's day and age. So sometimes that is the deciding factor, and I can guarantee I don't have an 024 because that's an oddball value. So that kind of rules out the Mylar. So it looks like the 027 is going to be the winner here because that's a big distance to span up there. I can't coordinate eyes and camera at the same time sometimes. That's a pretty big difference to span. So I got what should be, they might be 033s. Yeah, I was kind of thinking I could use these 027s here. They're a 100 volt chip, but they're not. They're 033s. So I'm going to have to use these 027s here that are just a little bit smaller. That kind of looks like it's going to be a perfect span for these 027s to go in there. So that's what we're going to use. Something to keep in mind. Oh, when you put when you space a chip up this high, there's actually 3 layers of spacing underneath this chip. Make sure that you don't have this taped too wide, because you're going to have problems laying the solder across the edge of that. So make sure that these edges are cut back, and prior to doing that, build up both solder edges on the board. That way everything just swipes into a smooth transition when you try to solder it down in. Otherwise, if you don't put a pad on here first, what will happen is when you try to hit this with the iron, most of the iron heat's going to be on the chip, and by the time any of the iron heat gets down here enough to flow, you're going to be overheating your chip. So I'm hoping that makes sense. So excuse me for sounding dumb here, but you know, it's just always a good idea, you know, to when you do something like this, just to keep all your parts together. It's a no-brainer, but you know, I say stuff anyway. That way you have them down the road. It doesn't mean that anything you change is going to be necessarily detrimental in some way, shape, or form, but there are certainly advantages to keeping the hold of stuff. So now this is where things start to get a little bit hairy, because I said go in the order of significance, and we're at this point. And this is the point that's just never quite so easy. This unit has a crazy amount of treble to it, and I could tell by listening to it there was ceramics in here for the high boost on the loudness, and they're 470 picofarad. So next I just want to figure out what I want to put in here, because we're really limited with what we have available readily today to put in here for a 470. We could put PPS chips, which could sound fantastic on a lot of music, but be tonally deafening to you on other music styles. So this takes a little thought here, what I want to do. There are just so many options here. I'm trying to sort this all out. If we look at this from a single component standpoint, one component to stick in here in place of these ceramics, we could use a polystyrene, we could use a PPS chip. That's pretty much it off the top of my head. But I know right now if I were to put a 470 picofarad PPS chip in here, this thing might be obnoxious. The other thing we can do too, which isn't on a single component level though, unfortunately. It's multiple components. Would be to say we wanted to make this as close to 470 as we could. We could put 1000 picofarad PPS chip in series with 1000 picofarad MKS chip. And the MKS would take some of the obnoxiousness out of it. I've done that in extreme cases, but that takes a lot of board room. On another note too, since this unit has so much treble, like I said, putting a single 470 PPS in here I think is going to be a disaster. I'm thinking that what we're going to have to do is put a series resistor in line with that cap to limit how much effect that cap has. And just off the top of my head, I'm guessing somewhere between 4.7K and 10K, which is going to control the slope of the high-end boost. If you were to, and you know, I'm not even going to try to do this because I'd have to have a piece of paper in front of me. But maybe I can do that another time. So we could certainly put a resistor in series with these and kludge it on the back here. Let me think other options. The other option is to decrease this and give the amp a little bit more air. It's going to boost at a higher frequency, but it's going to boost by a higher level by taking this down. And that way we may not have to put a series resistor in it. But there's just so many variables here, and I am not familiar with these STK modules. I don't know how they're going to respond compared to other things. So I'm just going to have to wing something here. There's a great chance that it's going to eventually get changed or tweaked, but I got to find a reasonable starting point. Okay, like I said, I don't want to get stuck on this. This is always the hard part on these things. Sometimes we got to go by what we have the most of. What do we have to lose the most? Because these small chips, this is certainly certainly something, getting tongue-tied, certainly something I won't reuse. So I'm going to go with what I have the most of, and I'm going to go with a 330. And I can guarantee if I put a 470 in there, I'm going to be tearing it out, wasting the chip, because I'm going to have to put a series resistor in. So I'm just going to decrease the value and add the series resistor to cut back on it. So we're going to put a 330 PPS chip, an ECH, in series with, let's try 4.7K. I just happened to think on a humorous note here, guy I used to work for, I was talking about getting hung up a second ago. And something he said to me at one point in time came back to me, and what he said was, do something, even if it's wrong. So that's what we're going to do. So there's our 470 ceramics that come out of there, and we're going to do something even if it's wrong. Here's our ECH 330s, and we're going to stick in some of these little guys. I always question this, 1/4 watt resistors, like the size of a 1/8 watt, but that's what we need, because we're going to have to squeeze this in there. So we're going to put two 4.7Ks, 1/4 watt by today's standards. So in goes our 330 chips first, and I just built up the pad here on this side, and we're going to try to cheat this chip as far over onto that as we can, because we want to keep a little bit of room here, because we got to get that little tiny resistor in there. So I had to cheat him over to the right. So now we'll do the next one. Same thing, build that up and just kind of swish him over. He went pretty far. Come on, come on, come on. I don't like overheating these chips. And I didn't set my iron back. I usually set it back to 600 when I'm doing those, and I didn't. I normally keep it blazing. It's at 800 right now. That's never good. So, just something to keep in mind. Alright, I'll tell you what, that really took some work to get these guys in there. I got them crammed in there. Clock says I'm out of time, so I think I'm going to take a break, put this back together, and take a listen to it, and just go from there and see what else we have to do. Thanks for watching. Have a good day.